Hey, Muso here. We're going to talk about momentum. This is the first of the videos on a series of videos on momentum. I'm not going to spend a great amount of time on this introductory topic. Just explain what momentum is, go through an example to introduce the equation. So, momentum. It's interesting. Momentum is a lot alike similar terms that we've already learned earlier in the year, such as, say, inertia or kinetic energy. But it's not really the same thing. So let's get down to it. It's the property of a moving object that makes it difficult to stop. Really, it's mass times velocity. Okay, so it's a vector term. An object with a momentum to the left is different than an object with a momentum to the right. And it will have units of mass times velocity. So it's simply going to be a kilogram times a meter per second, which is the kilogram meter per second. The variable for momentum is the letter p. That's a lowercase letter p. Don't ask why. I don't even know why. I'm sure there's a logical reason why they picked p for momentum, but obviously they can't pick m, right? Because mass is in there. So p is what momentum is. I'd like to think of momentum as an object, inertia in motion. Okay, so we need to have both inertia, mass, and it needs to have velocity. So a large object that's going slow speed might not have a very large momentum, but a really small object that's got a really high speed might end up having a lot of momentum. So it's not just inertia, mass and velocity. Okay. I think the best way of looking at what a momentum is to drop down an example problem. So let's go ahead and do this. We want to calculate the momentum of a 110 kilogram football player running 8 meters per second. We then want to compare that to the momentum of the football itself. So for A, I'm going to say the mass of the football player. So I'm going to say the mass of person 1. It's always important to indicate if there's more than one object with subscripts. So I'm going to say mass of the first person is 110 kilograms. The velocity is 8 meters per second. We want to know the momentum. Nice and simple, right? P equals mv. So we're just going to do 110 kilograms times the 8. And that's going to equal 880. And again, if we look at my units, it's going to be a mass times a velocity, so it's a kilogram meter per second. Awesome. B, we want to figure out the momentum of the football. Well, the mass of the football I'll call 2. That's 0.41 kilograms. Its velocity is going to be 25 meters per second. And so what's the momentum of the second object? Well, the momentum of the second object is, the mass of the second object times the velocity, or 0.41 times 25 meters per second, and we're going to get 10 and a quarter kilogram meter per second. So 10.25 kilogram meter per second. So clearly in this example, the football player had a greater velocity than the football itself. That said, I could have had a part C, and this would be ridiculous, but I could have. With what speed must the football be thrown to have the same momentum as the football player? I would have just done the 880 and divided by the 0.41. It would have been a ridiculously high speed, something that's a little crazy. My computer is going a little crazy itself. Alright, momentum introduction, nothing too tough. It's mass times velocity. An object that has a lot of mass and a lot of velocity has a lot of momentum. I hope this helped. Awesome. Thank you.